I'm Shana Ramalio.
And I'm Fatmi and Adam.
I'm Angel Perior Valeri.
I am here Julius T. Bagul.
Before we start, let us determine first the task. So, the task is to help decide what size the new sandbowl should be by determining how many of each cone could be filled with a cylinder of sand.
The first figure that we are going to solve is the cylinder, which is the ice cream bowl. But let me ask you first, what is a cylinder? How will you define it? A cylinder is a closed solid that has two parallel bases that is usually circular, that is connected by a curved surface. Now, to find the volume of the cylinder, we must know first the formula. Since the end base of a cylinder is a circle, and the area of the circle is pi r squared, to get the volume of the cylinder, we just simply multiply the height. So, volume is equal to area of the base, which is pi r squared times height. From the given task, we are given a measurement of 10 centimeter radius, 10 centimeter radius, and 20 centimeter in height. All we need to do is just simply substitute our given measurement to our formula. Volume is equal to pi r squared times height. So, volume is just simply copy the pi, and our radius is 10 centimeter. So, 10 centimeter squared times 20 centimeter height. So, volume is equal to pi. The square root of 10 centimeter is 100 centimeter squared times 20 centimeter. So, volume is equal to pi, and 100 centimeter squared times 20 centimeter is 2,000 centimeter cube. 2,000 centimeter cube times pi is equal to 2,000 pi centimeter cube. And this is our volume.
For the next figure, we have a cone. First, let us define what is cone. A cone is a three-dimensional solid object with a circular flat base joined by a curved side that ends in a vertex. From the previous discussion, we discussed about the cylinder. In this cylinder, we can create a cone with the same base and the same height. We already proved that the volume of the cone is 1/3 of the volume of the cylinder. From the given task, we are given a measurement of 10 centimeter in radius and a height of 20 centimeter. Now that we have all we need, we can now substitute the given values and then solve. So 1/3 pi, substitute r by the radius 10 centimeter. And then squared height by 20 centimeter. Squared is equal to 100 centimeters squared. Times 20 centimeters. And then 100 centimeters squared times 20 centimeters is equal to 2,000 centimeter cubed. Pi times 2,000 centimeter cubed is equal to 666.67 pi centimeter cube. Therefore, the volume of the cone with the height of 20 centimeter and a radius of 10 centimeter is equal to 666.67 centimeter cube.
For the second figure, we have a cone, and it's same as a first cone. We have a formula of 1/3 pi r squared height. The cone has given measure of 10 centimeters in radius. And the height is also 10 centimeters. And now, let's substitute all the values. 1/3 pi, and the value of radius is 10 centimeters squared times the value of height is also 10 centimeters, and then 1/3 pi 100 centimeters squared times 10 centimeters is equal to 1000 centimeter cube. (1,000 centimeter cube times 1/3 is equal to 333.33. 33 pi centimeter cube. And this is the answer of this cone. Therefore, the volume of this cone has a 10 centimeter in radius, and the height is also 10 centimeter, is equal to 333.33 pi cubic centimeter.
That has the same formula of the two previous cones, which is volume equals 1/3 pi r squared h. The cone has a given measure of 5 cm in radius and 20 cm in height. Now, let's substitute all the values. Volume equals to 1/3 pi, radius is 5 cm squared, and the height of 20 cm. So, 1/3 pi 5 cm squared is equals to 25 cm squared times 20 cm. 1/3 pi 25 cm squared times 20 cm is equals to 500 cm cube. Therefore, the volume of a cone has a radius of 5 cm and a height of 20 cm is 166.67 pi cm cube.
Now that we have all the volumes of the figures we need, the cylinder and the three different cones, let's go back to the task. So, the task is to help decide what new sand should be by determining how many of each cone shape could be filled with the cylinder of sand. First, we have to determine how many times thus this first cone should be poured to fill the cylinder. So we simply divide the volume of the cylinder to the volume of the cone. So the volume of the cylinder is I r squared height over the volume of the cylinder. Volume of the cylinder is equal to 1/3 pi r squared h. So here, the volume of the cylinder is equal to 2000 centimeter cube. 1000 centimeter cube over the volume of the cone, which is 666.67 centimeter cube. So 2000 divided by 666.67 is equal to 3. This cone will pour
3 times to fill the cylinder. So let's go to the next cone. So the process is the same. The volume of the cylinder 2000 over the volume of the second cone, which is 333.33 centimeter cube. So 2000 divided by 333.33 is equal to 6. The cone will be poured 6 times to fill this cylinder. Then we go to our last cone. So the cone, same process, the volume of the cylinder over the volume of the last cone. So volume, which is equal to 2000 centimeter cube over the volume of this cone, which is equal to 166.67 centimeter cube. So 2000 over 166.67 is equal to 12. Now that we already proved that this cone will be 3 times to fill the cylinder, this cone will be 6 times, and this cone will be 12 times with their different volumes.